Hello, everyone. Good afternoon and welcome to the CCSQ DNA Town Hall. For those of you who are new, these calls are designed to provide you with updates, announcements, and training demos related to the CDR, SaaS via Databricks, and more. So let's cover some quick administrative announcements before we get started today. So just some reminders, please stay muted during our call to minimize interruptions. Please use the Zoom chat feature to ask any questions to be answered during our Q&A portion at the end. Our last couple of town halls have been really content heavy, and obviously that's what we want to prioritize. Today we do have 2 demos as well. So if there's a chance that we don't get to any Q&A portion at the end, please still ask those questions, and that way we can get them to our team. And then all questions will be published, whether we answer them live on the call or not. And then those will be published to the portal page following. And it will, right now it says all material to be made available in Confluence. They will be in Confluence, but we are switching over our past events all to portal at this point. So it's going to be made available there as well, which will be the link we're going to be sharing out after the event. So today's agenda I'm going to kick things off today with some information about our fall data camp. Then I'll be passing things over to Caitlin with some incoming data announcements. Then we're going to be covering Databricks Spark runtime cluster release. Then Miriam will be giving us some information about our most recent monthly satisfaction survey. And then Derek will be closing things out with 2 different demos for us today. And then, as I said, our last piece there would be the Q&A if we get to that. So first will be our data camp topic survey. So for those who don't know me, I'm Julie Amdy. I'm a communication specialist on the PM32 contract. So I do facilitate a lot of different meetings and events. So you may have seen me at different things like the QNet chat. One of those is the CCSQ DNA data camp. Our newest one is going to be happening in November this fall. So about mid-month. So please keep an eye out for a save the date that will be coming soon. At the end of our last data camp in May, we did collect some information, and there was a question that said, what topics would you want to see this fall? We are absolutely keeping that in mind, but as new things come about, and you may have new things that since May you want to hear about that you didn't put on that survey or you weren't able to attend and give us that information. So with that being said, we would like to get some information from you today. So this survey does help us plan our data camp sessions that best align with the needs and interests of the CCSQ DNA community. It will be a SurveyMonkey link that Rachel's going to be sharing in the chat here shortly. We will encourage you to take the survey as soon as our meeting ends. So please take that link and bookmark it, move it over so we don't lose it. It will be remain open until 5 p.m. today. And then as a reminder, the survey is anonymous, but if you do, one of the questions indicates if you have something you would like to present yourself or need to give us your contact information. That does allow us to follow up and provide support or answer any questions where needed. So I believe Rachel shared that with you now. So please give us your feedback. We love to hear it, and we love to use that to help us plan a great event for you. And then, as I said, more information will be coming in the coming months and weeks here with our fall data camp and a save the date. So with that being said, I'm going to pass things over to Caitlin now for some incoming data announcements.
Thank you, Julia. So we can go to the next page. So some new data has been introduced to the CDR in recent months, including MedPAR, MCBS, PRS 2.0, and FDA historical NDC. So that's retaining NDCs after they drop from FDA's NDC directory, where before those were just kind of vanishing. And there's some more to come. MBISG and HQR exceptions should be available very soon. Think in terms of days, not weeks. We don't have confirmed dates for NHT yet, but we're aiming for sometime this fall with that. And then there'll be more information coming soon about the iKeys schema changes. These are related to process improvements. They're not scary changes, so never fear. Note that access to everything in this list, except for the FDA historical tables, will require having the right entries in your org's DUA. For more information, please visit the data catalog in Confluence or contact the help desk. Thanks, Julia.
Thank you, Caitlin. Okay, so next we are going to be hearing about Databricks Spark time run clusters with Ron Espino, and I'll pass things over to him now.
All Thank you, Julia. Okay, so next slide. Right, I'm giving an overview regarding our Databricks Spark runtime upgrade, giving you guys, the purpose of this release candidate cluster. Why are we doing this? As a program, we're committed to maintaining optimal performance, security, and access to new features by periodically upgrading Databricks runtime environment. So to facilitate the smooth transition, we're providing release candidate clusters that mirror your existing setup, but operate on the latest runtime upgrade version. But the benefit of this is to allow users, you all, to test out new features, enhancements, and check your performance and provide any improvements in a controlled environment before we apply this change to the production environment. This is a proactive approach to help us avoid any unexpected issues and ensure your workflows are continually running smoothly. And the availability of this, I'm pretty sure you guys have seen this. The clusters are labeled with the wording candidate. So they are provided. And we also, earlier this month, I believe we released an announcement that these clusters are available for use. And typically we have designed this for like the next 45 days for usage and testing. Our current upgrade is scheduled in the first Friday of the next month, which is, I believe, September 6th. So that's when we will be upgrading the current production clusters to the latest runtime version, sorry. Why are we doing this? The importance of this is that making sure that the code that you have is, tested properly and it runs correctly in the current version, the latest version of the runtime upgrade. And any changes in that environment, even minor ones, as you know, can impact the behavior of your scripts, queries, application. And by being able to test early, you can identify potential issues and avoid any disruptions when the upgrade is rolled out in our production environment. Responsibility falls to everybody to make sure that you are testing your code during this release candidate period. And this is essential to ensure a smooth transition to the latest version of the runtime. Adjusting your code, as you all know, we are here to help you out if you need further assistance. But mainly the purpose is, of course, ensuring that if you encounter any issues, make those adjustments, making sure that your code is compatible to the latest Spark runtime version. This, of course, is the opportunity to optimize your script and take advantage of the new features that will be available in the latest runtime. And as I mentioned, the upgrade will take place September 6th. So after that weekend, when you come back on the 9th, the current your cluster will be up to the latest version. Please do some final checks and make any adjustment. Retest your code to confirm that everything works, that you were checking on the release candidate clusters. And official update will be hopefully minimizing any last minute surprises. A long-term impact of this is, successfully upgrading your code will allow everyone to leverage improved performance, enhanced security, and new capabilities offered with the latest Databricks runtime upgrade. And of course, helping everyone to, and your team to be efficient and productive. In summary, your engagement during this testing phase is crucial for a seamless upgrade experience. And you please use this opportunity to validate your code and make necessary adjustment and fully benefit from the new runtime features. And of course, thank you for your cooperation and commitment in maintaining a high performance data environment. Julia?
Thanks, Ron. Okay. So next we're going to be moving to our monthly satisfaction survey review with Miriam. So Miriam, I will pass things over to you now.
Thank you. As we've expressed in past town halls, we do value your feedback. So we're going to quickly cover July satisfaction results. We have made some changes in our process, and I think we're starting to see some of the effects from it. From our last survey in town hall, 80% of you all indicated that you are satisfied with the performance of and uptime of the environments, which was a 27% increase from June. 50% are satisfied with help desk support for the CCSQ DNA environments. This was a decrease of 12% since June. We are still trying to implement our new standard operating procedures. And one of the main feedback that we got back with the last survey was communication in too many locations. So this is something that we're looking at as well. And then the last one, 70% of you all indicated that you're satisfied with the resources that are available in CCSQ data analytics. This was a 15% increase from June. Next slide, please. Just to call out some positive praise and feedback that we've received, we had some feedback that Databricks has been running faster or has a faster runtime and has more functionality. You also stated that you appreciate the new Databricks AI assistant, so glad that is providing value to you. The data camp resources located in Portal have been useful. We are continuing to update content in Portal on a 2-week cycle, so make sure you're checking out Portal to see new available content. And then we had a shout out to Jessie from Alliant Health Solutions for her demo last month to show her effort with her SaaS to Databricks migration and the steps she took to convert all her code over. And then the next slide, please. So some suggestions and improvements that you provided within the environment, providing code examples, more code examples. It's limited to simple situations, and you would appreciate more complex examples. We've taken this feedback back. We are working on a new feature to provide more examples, so stay tuned for that. Help desk, this was the feedback that I was referring to earlier. Just the interaction with the team can become difficult to manage between tickets, Slack, email, etc. So we have started reviewing that to see how we could ensure that you're not having to check multiple locations for updates. And then training material, the suggestion here was more advanced training and how to access data and successfully join tables. We will be reviewing this and putting some KBs together, training articles together, and getting them published out to Portal. I think the next slide. This is just a recap of what we covered last town hall with the performance and uptime. As Ron pointed out, the team is proactively working to support SaaS, resolve system issues, and further stabilize the environment. With help desk support, we do have that ongoing coordination between the 3 levels of help desk to really start enforcing the new SOP that we've implemented. And then available resources for SaaS via transition specifically. We are continuing to build out those knowledge base articles and training material out in Portal, including the shared notebooks. As Julia mentioned earlier, previously all the past town hall and data camp content was on the Confluence page. Those have all now been migrated over to Portal with a new section under past events that is available as well. And then office hours, we are still holding these sessions, so make sure you are watching for those emails and signing up. We did increase registration to 25 spots for new topics, and I believe 40, maybe 50 for repeat sessions. So those are available, and then after the session is held, the event is updated with the content and material that was used and covered during the office hour session, along with the recording. Okay, we're ready for the next slide. And this, as I said before, we do value your feedback. We appreciate it when you guys take the time out of your day to complete the survey. It does help us improve and try to make the environment and everything that we can provide to you better to help facilitate your day-to-day actions. And I think Julia's going to take it over from here to kick off the survey, I believe.
Sure thing. Okay, so This survey that we're going to be sharing, we are just putting the link as a reminder. Rachel just dropped it in the Zoom chat. It helps us know what we can do to improve your experience within the CCSQ DNA environment and community. The results will be used to improve our tools, trainings, and offerings. So it is another Survey Monkey survey. We do encourage you. So it has been shared now. We encourage you to take the survey as soon as our meeting ends. The survey will remain open until the end of the day. Please only submit a survey if you're a user within the CCSQ DNA environment, and that reminder does pop up when you do open the survey. So again, please do it as soon as our meeting wraps, but if you have time later in the day, that'd be great too. We've been sharing that link in our Slack posts, and then in my email today that was like announcing Townhall is coming, it's in there as well. If you lose it in the Zoom chat. So as a reminder, this survey is anonymous, but providing your contact information does allow us to follow up and provide support where needed. So if you do have a very specific question or you need support, definitely leave your contact information there so our team can reach out. Okay, so with that, we are going to be passing things over to Derek for pretty much the remainder of our town hall meeting today, so he can give us some great demos. So Derek, I am going to pass things over to you now. Maybe.
Yep. Thanks, Julia.
There. Okay.
I'm not sure if I would have used the word great there, but okay. I will share my screen.
No, the demos are always a highlight. It's always great. All right, I'll drop screen share now.
All right. So the first thing we wanted to try and talk about is the new feature within Databricks that everyone should have access to, which is the SQL editor. And what is it? How is it different from SQL language programming in a notebook? What are the advantages? What are the disadvantages? Things of that nature. So I figured I'd go ahead and just kind of start with a very high level overarching diagram that's going to explain what the SQL editor is compared to what notebooks are. So, as everyone is very well aware of up to this point, notebooks run on compute clusters. Everyone's got an organizational compute cluster. You've got the ability to run Python language, SQL language, R language, Scala, if you want to use Scala, and you have access to database tables to be able to read database tables based on your DUA, write database tables, bring those into data frames if you need to, whatever you want to do. One thing to note as of right now today, when we do write new database tables with a notebook, the underlying files that are being stored for the actual database tables are actually Parquet files. So what is the SQL editor? And how is that any different than having a notebook with SQL language? Well, the SQL editor is exactly what you would kind of think it is by saying it's SQL editor. It can run SQL queries. It is only specific to actual SQL language. The biggest difference here is going to be what kind of a compute it's utilizing when you are reading and writing database tables with SQL language. It is going to hit what is referred to as the SQL warehouse. Not using a compute cluster like your notebooks use, it utilizes a SQL warehouse. This is actually the exact same type of compute that SAS connects to when you are utilizing some of the SAS macros to connect to Databricks to read database tables, and maybe you're writing database tables or you're reading them and writing them to SAS data sets or whatever it is you might be doing. SAS is connecting to this SQL warehouse to execute all of the SQL queries that you're passing. And one thing to note here is that by default, we are writing the underlying tables as Delta files, which is very similar to Parquet, although it's slightly different in the fact that it allows for what's referred to as sort of like ACID types of work, which means you can basically modify and update existing database tables rather than having to kind of wipe data tables out and then completely recreate them if you're adding a new column to a table. There's a lot of other really good benefits to Delta tables that we will get a little bit more into on the road with maybe data camps, office hours, or town halls. One thing to note is that Databricks really does very well from a performance perspective when it's reading and writing Delta tables, although the Delta table is essentially just a bunch of arcade tables wrapped around some additional things, but not to overcomplicate it and get much into the weeds. Delta tables are very efficient, and Databricks runs very quickly with Delta tables. So, get more into it. Why would somebody want to use SQL Editor versus a notebook? So let's go to Databricks here. And what you can see, we have a SQL Editor, and what I'm currently in right now is a notebook. What's a SQL Editor look like? It's simply an editor that allows you to write SQL code. Same thing with a notebook, right? This allows for, you still have your command windows, you still have the ability to do markdowns, but this is being attached to what you can see here is to our CDR PDA QDAS compute cluster. What you can see here is that this is being attached to this SQL endpoint warehouse. And so one main thing that is very specific, again, is that you can save queries, but note that queries are just that. They're queries. They're not notebooks. When you go to open it up, it will open it up within a SQL editor, and it's going to be an actual SQL query, which means the only thing you really can utilize this with is going to be database tables right now. So if you're reading database tables and you're writing to database tables, having the SQL warehouse is probably at this very point in time going to be a little bit faster, a little bit more efficient when you are executing that code compared to your notebook. If you're running it with a SQL language, this is going to be executing on your organizational compute cluster. You've got certain resources that you are being shared across just your organization. The SQL warehouse, it is being shared across everybody, but what the SQL warehouse has for advantages is the fact that it is a pretty large compute cluster compared to some of the actual regular compute clusters, and it's constantly up. There is no auto termination, so you don't necessarily, if you've got something on a schedule to run, you don't necessarily have to sit there and give it 3, 4, 5 minutes for it to be spun up. It will automatically execute it because it is constantly up, and it will read and write Delta files. It does have the ability to read Parquet as well, but everything that you're going to be writing out is going to be a Delta file. So if you're going to do further processing of that table, it is going to be a little bit more efficient in how Databricks processes it. So I have some example code here we can just run. I'm not going to display anything here because this is claims data, and we certainly don't want to do any of that because not everyone has a DUA with claims data. Just a brief example, upping the table, if it exists, creating a new one, where I'm just going to pull in unique list of beneficiaries, and then I'm going to run an alter table to make sure that the owner's being set to our organizational group. I'm going to do an analyze table and compute statistics on it, and then I'm going to run a describe formatted statement. So what this does is it's going to analyze the table. It's going to give me all of the different columns that are in the table, the data types of the columns, underlying file locations, and then it's going to also provide me statistics around the table as far as like the number of observations and how large the table is. And you can see here and kind of how it's executing. It runs all of these different sort of query profiles to make sure that what it's doing is going to be optimized before it then runs to actually execute the actual query itself. It does the same thing in the notebook. It might not be quite as detailed in as far as like what it's doing unless you go into the compute logs. As you can see here, this ran in 31 seconds, almost 32 seconds. I can see I've got a table here. It has 584,160 rows. And so we know it's got the one column and what the data type of that column is. And so I can run the exact same thing on a notebook, right? It's not a big deal. I've broken this out into some sections. And we'll notice it might take a little bit longer to run on your compute cluster. It really kind of depends who are you competing against. But in all reality, it's going to be relatively similar. But we do have the ability here to schedule queries, to save queries. One thing I wanted to show is what it looks like when you look into your workspace. And again, all of these are going to be available within our DBX demos folder under our CDR PDAQ workspace. But you can see here, we have notebooks, and this is a query, right? So that is all that this is. It is a query, and you have the ability to edit that query, you save it, and you can schedule the query. Obviously, you'd have to add the scheduling in order to schedule it, and it will run on the SQL warehouse. When we look at this, so this, again, this took, what did it take? Couple minutes compared to what this ultimately took was 32 seconds. I guess this took 34 seconds, sorry. But yeah, when you're looking at what you're pulling from, what you're producing, notice this is a Parquet versus when we look at here, it's the Delta. So that is a little bit of a difference, right? So your Parquet, underlying Parquet files versus Delta files. At the end of the day, it's running the exact same thing. It's just you're a bit limited because you can only run SQL. But if what you're doing is simply query, like you're pulling data from, you're reading data from SQL tables and you're writing to SQL tables, it very well could be a lot more efficient doing that within the SQL warehouse and saving those SQL queries. And then you can schedule the SQL queries rather than actually running them within a notebook. It's really dependent on what it is you're wanting to do. And if you're wanting to bring this data down into your workspace, your S3 workbench, or if you're wanting to do further manipulations of the data, then you would maybe want to consider using R or Python with data frames. But at the end of the day, if you're simply reading and writing from into database tables, highly recommend you just take a look at creating some SQL queries and using the SQL editor to run those, and you can put them on a schedule and certainly take a look and see, is this going to run faster than if I was to run it on a notebook? Again, what you're seeing here, it's really not significantly faster, but it is a little bit faster. And some of the benefits are that it is a larger cluster, so it can spin it up, and it's constantly spun up. So you don't have to kind of wait for that natural spin up of your own compute cluster. And that's really kind of what I had to kind of talk about some of the differences, some of the benefits between using the SQL editor versus using a notebook and SQL language. With that, I'll kind of move on to the next piece, which is to talk a little bit about some new libraries that are automatically being loaded to compute clusters.
Hey, Derek, real quick, we had 2 questions come in on that topic. Would you rather circle to those to ensure you get to your next topic? Do you want to do them after, or would you rather?
Let's do them after the next topic.
Okay, that sounds good.
Yeah.
Okay, cool.
So what we are going to talk about is a couple of new packages that are available on all of the compute clusters and how you can utilize them. Specifically, what I want to talk about right now is reading SAS data sets. that might be stored on your S3 workbench. Obviously, as most people know, the file extension is a .sas7bdat file, which just means it's a SAS data set. Currently, what we've looked at utilizing for packages to be able to read those into some kind of a data frame within Databricks is either the actual SAS7bdat package, or there is another package. For some reason, I am drawing a blank on the name of it right now, that we had identified that can read it in. But what both of those packages have to require is that everything is ran on the driver node. And the fact that this SAS data set needs to be copied to the local file system on that driver node. And the reason for this is because of the fact that it's utilizing the pandas package underneath. And the pandas package, as many people know by now with Python, does not have any sort of a Spark integration. So it does not have any distributive processing of the data. And it is using, it's 100%, all of that data is being read in memory on the driver node. So being able to read in SAS data sets has had its limitations based on the size of the data sets that you might be reading in. If they're 32 gigabytes or larger, you probably have to wait an incredibly long amount of time, or you can't even do it because you run out of memory. What we've done to get around this is we've been able to identify some Maven Java level packages that are now available automatically when the cluster is spun up and can be utilized to be able to directly import the SAS data set as well as Excel files directly into a Spark data set, specifically for data frame, Specifically, when we read from the mount we're creating, it allows for the worker nodes to have all of that direct access to that mount, which is just simply where your S3 bucket is located. And it allows for those worker nodes to read and load that data across all of the worker nodes. And now this data frame is a Spark data frame, and it's distributed across the worker nodes as well as the driver node, instead of it all being 100% on the driver node. This is going to allow a lot more flexibility and a lot larger of SAS data sets to be read into data frames for further processing of however you may want to do that. What I want to do is kind of demo how that works and what it looks like. One thing to note is what these packages, these libraries are. So when we look at our QDAS package, we see these libraries, and we can see here we've got a couple of already installed Maven libraries. One is a Spark Excel, another one is a Spark SAS7bdat. So how can you utilize these? Starters, we'll start with the Spark SAS7bdat file. What I'm going to do here is, and what I've done here is I've linked documentation directly to the package, which really allows for you all to maybe take a look and see what's all of the available options, what's all the syntax that's available to you to kind of utilize this and take advantage of it. But what I want to do first here is I'm going to mount my S3 bucket onto the DBFS mount directory, and not on just the mount directory, but I'm actually mounting it to a subdirectory underneath this mount. So please, people, do not mount anything directly to the MNT folder. This breaks everything for everybody. You need to be mounting it to a subdirectory. And what I'll do here running this is it's just going to mount path using the dbutils file system mount functionality. And then I'm just going to go quick look at what files are in that S3 bucket workbench for me to be able to access. And it's just going to display it to me. Take a look at it. This is, again, of course, the same exact location that your SAS workbench in SAS Studio is on, as well as if you've set up your file shared setup within the managed file transfer application. So What I do know is that I've got a SAS data set located in this directory. Of course, here I'm only going to my user folder, and then I know I've got some subdirectories under my user folder where this data set is located. How to read this directly into it is simply read spark.read.format. The format that we are calling here is this sourfang, I probably butchered that, .sas.spark. I'm inferring a schema, meaning I want Spark to kind of read the data and assign it what it believes to be the specific data types within the data frame. And then I'm just simply loading this SAS data set into this df_SAS data frame. And what I'll show you here by running this is that the actual class type of my object is a PySpark.SQL.DataFrame. This is actual SQL Spark data frame. I'm printing the schema of it. So what I can see here is that I've got 4 columns in it. All of them were assigned as a string. And then I'm just taking a look at the top 10 observations. And so what I've done is I've actually printed the same thing out as a SAS data set where it's located on my workbench. And you can see the same thing. I've got these 4 columns. Obviously, it's not a very big data set, but what I want to show next is doing a little bit of a larger data set and how quickly you can do it. So with that in mind, I'm going to take a larger data set here. I'm going to take this Benny MA coverage data set. Again, I'm not going to display anything because there's certainly things in there that I can't display. But what we can see here is this data set's got 2 gigabytes. We're looking at 34 million records, a little over 34 million records in the data set. And so I'm just going to go ahead now. I'm updating my SAS file value to be a different location, different name, in the same spark.read.format. And what I can show is how quickly it's able to access this and load it into a data frame. So now I've got 2 gigabytes worth of a SAS data set within a Spark data frame that I can go in and I can do whatever I want to with it now. And it was just that quick. It took about a second. Again, you will still have some limitations because it is utilizing the worker nodes, and there is a maximum amount of memory available, even if you have all of the worker nodes spun up with the driver. But it's significantly more space than if you're simply working 100% on the driver and you're utilizing the Pandas Python package to read this data set in. One thing that is very unfortunate that we should note is that it does not have the ability to write SAS data sets from a Spark data frame. The only thing that this package allows us to do is read a SAS data set and write it into a Spark data frame. If you have a Spark data frame, you cannot use this package to write a SAS data set, which makes a lot of sense because with SAS, obviously, you've got to read all of this data through a PDV in order for it to actually be processed and written as a SAS7 BDAT file. So can't write SAS data sets. You certainly can read them and read large ones into distributed Spark data frames. So moving on to the Spark Excel file. Again, this is very, very similar to how perhaps it was done previously, where maybe we were using OpenPyXL with some kind of Pandas package where we're reading in an Excel file. Again, because it's utilizing Pandas and it's not Spark, it's not distributed, all of it is happening on the driver node. And the file has to be copied over to the local file system on that driver node to be able to read it in. Here, it's no longer the case. We're going to read it directly from our mount. Basically, we're reading it from S3. And again, we are writing it directly to a Spark data frame. So it is not being all in a single data frame only on the driver node. It has its distributed processing, and the data is distributed across the worker nodes. So again, here, We can see there's an Excel file that I have that I'm aware of. That Excel file looks like this. I actually have a pivot table in the Excel file. I've got a code lists tab, and I've got a medications tab. Again, I've included documentation to this package so that everyone can take a look at what are all of the options to utilize, what's the different syntax to be able to utilize, to really understand what all is possible when it comes to reading and writing this stuff. So what you see here, spark.read.format, and here's the format that we're utilizing, this Crayolytics Spark Excel package. I'm setting it equal to importing this code lists tab. I want to start in cell A1. I'm letting it know that the very first row of my Excel file can be headers. I'm also inferring it to infer the schema to apply what it believes to be the natural data types within the data frame itself. And then I'm simply loading the Excel file. So we run this. Again, I'm going to print object here of my data frame. You can see it is Spark data frame. I'm looking at the schema. You can see I've got value set, code, definition. It's all the same. And then a quick look at the actual data itself. And this is now a Spark data frame. I've written this out. Yeah, I can move forward with it. If I want to write it to a database table, if I want to do something with other data frames, whatever I want to do with it, it's ready to go. And again, you can see here, I don't know where that went. Just simply reading exactly what we would expect it to be reading out when we're looking at the top 10 observations that it read from. So one last thing I want to talk about and show is the ability this package has with writing a Spark data frame out to an Excel file. Now, this does take a little bit of time because, of course, with Spark, it's got all this data distributed, right, across your worker nodes. And so what it ideally wants to do is write multiple files for each of the different worker nodes that the data is loaded to. What this package is going to do is it's going to have to take all of that data and kind of transition it into the driver node to then be written out through that driver node so that it can write it out to a single Excel file. So it will take a little bit of time, especially if we're talking about an incredibly large amount of data that we have in a data frame when we go to try and write it out to an Excel file. But it does give you that ability to write to an Excel file, and it gives you the ability to write it dynamically. Here you can see I'm writing it to a new Excel file. I am actually naming the code list demo tab that I want it to be named. And I'm going to write it to A1, but I don't have to. I can tell it to write to C1 or whatever. I am saying that my first row is going to be headers, that I want it to be called headers. And then the type of mode is an overwrite. You can also append to an existing Excel file if you need to. Again, utilizing this link to take a look at what's all out there is certainly something I would recommend everyone does to see exactly how they might be able to utilize these to whatever they want to do. So then the very end here, we're simply saving the Excel file. And what I will note is that this Excel file does not exist currently. I'll show you that through MFT. Of course, it logged me out. Under my network shares. Sure. That was a rerun. Yeah. Okay, cool. Yeah. So I will go ahead and run this. And so I'm calling it DBX demo output. Ran pretty quickly. Obviously, DBX demo output doesn't exist here as an Excel file. I can simply refresh. And now I have a DBX demo output.xlsx. I wanted to take a look at this. You'll notice it has exactly what the previous one had. And I've got my code list demo tab that it created. Maybe I want to do this a second time. And I want to append it. And I want to call it demo2. I have not tested this, so if this errors, I apologize. But I now have an updated Excel file with a second tab. So obviously, there's a lot of good functionality here that we highly recommend people utilize because of the fact that this is Spark packages, and it utilizes that Spark distributed processing, as well as the ability to distribute the data across those worker nodes. And then the last thing I'm going to do is simply unmount my mount path I had created initially at the very top, so that just kind of a cleanup type of thing. All right. I will take some questions now, I suppose, Julia, if you want to do that.
Okay, yeah, I'm gonna keep you screen sharing in the event that there's anything you need to like physically show people.
Okay.
So our first couple were for Ron. Should we circle back to those later and primarily focus on the ones from your demo first while you're screen sharing, you think?
Yeah.
Okay. So can variables be assigned in SQL Warehouse?
Can variables be assigned in SQL Warehouse? Variables as in, like, if we're scheduling, we create like a schedule and we pass, like if we're creating a job and we want to pass a parameter, or what kind of a variable specifically? So if they're using PySpark and you can pass variables kind of like macros in PySpark, that's possible. But with SQL, I'm not sure if there's the ability to pass variables on this new Databricks runtime version. There might be that ability within the notebook to pass variables.
Okay, Derek, we got clarification. Yes,
Okay.
similar to PySpark SAS macros.
Yeah, so there may be possibilities now with the new Databricks SQL or Databricks runtime, pass it with regular SQL in a notebook. I know a previous runtime version did not allow us to pass those. You can pass parameters within a job. If you're scheduling a job to run, you can pull those in as widgets. But SQL never really actually let you pass parameter values previously, unless you were using PySpark, which is not SQL. It's technically Python making a SQL API call. I don't think I really fully answered the question, unfortunately. We can look more into it, but there's definitely parameters you can pass for your SQL query when you're creating a job for the actual query to run, if you need it.
Okay, she said thank you. Then, have there been issues identified to date with the new cluster? Nope, sorry, that was from earlier. Could you share on the Confluence a list of things or examples when it's preferable to run a SQL query in the SQL editor versus SQL in the notebook for all the things you're explaining right now? Now, this was for the first part you did. That way it'll be ready for reference for all, and several people like repinned the same question.
Yeah, we can put something in Portal that kind of talks about best practices and like when you might want to utilize the SQL queries with SQL editor in the warehouse versus just using SQL language within a notebook. We can look at publishing something like that.
Okay, then can you create temporary tables in the SQL warehouse?
Temporary tables.
That's what it says.
So I'm assuming this might be similar to, again, that's kind of a PySpark thing. It's not an actual SQL thing. You can always create a table and then drop it. Highly recommend you're always utilizing your organizational schema when you're writing stuff. I know there is the ability to create like temp tables or temp views if you've got a Spark data frame when you're using PySpark in a notebook. But again, that's not SQL. Like you're not really, SQL is very much, create table, whatever, as it's there's different types of tables you can create. Like I don't know about actual temporary tables. I would have to look a little bit more into that to determine if there is a way with true ANSI SQL to create a temporary table.
Okay, so I think in the office hours demo, it was shared that SQL can be used only to access catalog data, not workbench data. If this is correct, if it is correct, will there be a way to access workbench data through SQL editor in the future?
In the future, I'm not 100% sure. I'm going to say no because of the fact that SQL is a database language. Even if we're on Unity Catalog and we have the ability to get workbenches out there, like SQL is database. And so it's got to be databases, tables that are registered within metadata, catalogs. It's not something that you can just use SQL to go out and read Excel files or CSV files. Like it doesn't work that way. Because SQL is very much just a database language. That's Python, that's R, Scala that can utilize that.
Okay, we have 2 more minutes, so let's do one more question before we wrap today. And then as a reminder, all of our other questions will be answered in our Q&A portion and will be published to our portal site after our event. How does Maven handle SAS date and date time columns?
That's a very good question. That is not something that I have tested, that the team has tested yet. But that's a very, very good question and something that we can certainly test out and take a look at. And once we kind of identify different types of formats of those dates, what does that look like on the Spark data frame side? And we can communicate that out. Something also that the user community can test as well. Yeah, I don't have that off the top of my head. What I want to initially guess is, no, I don't want to guess anything. I don't want to say something that might not be right. So yeah, it's something that we as a team will go back and test and take a look at with different types of date formats and how those get read in to the data frame. But also something that everyone can kind of test out as well too. So.
All right. Well, at this point, it is 1:59, so I'm going to wrap our Q&A portion up here. But as I said, anything that was not answered by Derek or Ron verbally, we'll make sure to get those questions to them, and the team can work together to get you answers. They'll be published to our portal space, and then I'll be sharing out a Slack post once all materials are made available. But in the meantime, you can keep checking back. Please keep an eye out for, at this point, I'm not going to share my deck again just for one screen, but thank you so much for joining us. Thank you to our presenters, and please keep an eye out for any other resources that we're going to be sharing, our newsletter that's coming up, and then our September town hall as well. So in the meantime, I got our questions recorded. I'll get those over to Derek and Ron. And thank you so much for joining us today. We'll see you next time.